Hi, my name is Marco Cantu. Welcome to this webinar about ARC, automatic reference counting in Delphi. What we're going to cover is, after a very short introduction of memory management and some of the core ideas around it, I'm going to spend a little time on reference counting, traditional reference counting for strings and references. And then I'm going to focus on ARC for objects, covering weak references, unsafe references, and some other cases. And at the end, we'll get back to interfaces, because interfaces got some new features recently in the Delphi language, like weak and unsafe interface references. So I'll go back to those after going over ARC for objects, which is available only on some of the platform that Delphi targets. So let's start with the basics of memory management, and I guess most of you would 100% know everything here, but just in case someone is not such an expert in memory and how things are allocated, let me recap a couple of things, and at least explaining that the way I use terms, because that might be confusing for some. So global memory is what you get when you declare a global variable. The lifetime of like an integer. A lifetime of global memory is the entire execution of the project. That should be seldom used, if not never used, but that's a separate topic. So global memory is available. A case of like modern use of global memory when you have class data. Class data takes global memory and has a global lifetime. And in fact, there's a way to initialize class variable using class constructors and class destructors that matches the global lifetime of that data. The stack is last in, first out data structure that's basically used for parameters of functions, procedures, method calls, and the local data of such functions, procedures, and methods. Similar for anonymous method, but that's slightly more tricky, and I'm not going to cover it. So all of the local variables are declaring a local. The lifetime is the function execution. When a function calls another nested function, you get another stack, another area of the stack, and this gets added, and then last in, first out. The stack is unwound, and it goes back to the beginning. Well, it never really, because that's only when the program terminates. This is automatic in terms of lifetime management. Of course, if the data is really local, so this is separate from an object. Most of your data lives on the heap, which is dynamically allocated and in random sequence, so there's no sequence of allocation, because the allocation and destruction is up to the application. Mostly up to the developer, sometimes up to the runtime system. It can be any lifetime. You can have long life and short, an object that live for milliseconds or even less than that. It really depends on the application. You can have objects that you reference from global memory, so the lifetime is basically the entire execution of the program, almost. And again, there'll be a local data that refers to an object that's created and destroyed within the function call, and so in that case, the lifetime is extremely short. So on the heap, basically you have something on the heap that is referenced or has a pointer if you're going low level, but mostly a reference to the heap block. So that's the classic structure of an object. You have a reference, the variable of object type is just reference to something in memory. The only notable language that does things differently is C++. Any other modern language, from C# to Java to the dynamic languages, tend to use objects, an object reference model. Of course, that comes an issue that every block that you allocate, you have to free. If you don't free an object, and you just get rid of the local reference, then you have a memory leak. There's another issue that is as complex to handle, which is every object should be described only once. But again, I'm not going through all of the free and nil type of things in this session. But just remember that there is also the opposite rule. You cannot destroy the same object twice. That's not really going to work, or can really get you in trouble. So what's used as local memory or value type, or what's a reference type in the Delphi language? Local memory is for native types, ordinal, string, floating point, whatever. It's used for short strings, although we kind of trying to get rid of those. It's used for records. That's very significant. I mean, records behave in a completely different way from objects or classes because they are locally allocated. And also static arrays. I mean, array 1 to 6 or 0 to 5 is allocated directly in memory. Most of the types you're using use heap memory. That's true for all strings type, from ANSI strings to Unicode strings to UTF-8 strings to any other string type that's not a short string. It's used for classes, so any object. Interfaces, well, it's still interface is just reference that goes to an object or a class. It's used for dynamic arrays, and it could be used for pointers. I mean, pointers are just a pointer, so a pointer can refer to local memory as well. But if you are creating an object through a pointer, allocating the memory for the data structure, then it's going to use heap memory. So the first thing I want to mention, getting to some actual user scenario, is of references and reference management, is string reference counting. Strings have started using reference counting in Delphi 2, so it's been quite some time. And in short, it means that when you're saying S1 equals S2, I mean assigning a string to another, you're not making a copy of the data. You're just increasing the reference count of the same string in memory, and both S1 and S2 get the same value, and they're just aliases of the single string allocated on the heap. Whenever you change one of the two, either S1 or S2, there is a copy, so it's called copy on write, because the change is done only when you're changing the data. It does work very smoothly. I mean, you seldom have to worry about memory for strings. However, it has side effects. I mean, the side effects of that's shared by all managed type. For example, when declaring a string on a local block, you get a hidden try finally block because a string is a managed type and needs to be cleaned up. If you have a string on a record, when the record goes out to scope, the compiler has to inject some code to decrease the reference count for the string and eventually remove the string from memory. So all managed types have incur into overhead finalization code and hidden try finally blocks, and strings make no exception to that rule. There's another thing that's important. If you don't plan changing a string passed to a function, you can, or actually should, pass the string as a const string, because that's an optimization. When you're passing a string as a const string to a function, the extra overhead for increasing and decreasing the reference count is doesn't happen. I mean, if it's const, there's no decrease of the reference count, and so that's can make the code a little faster. I mean, little meaning very little if you're calling the function once. I mean, if you're calling the function millions of times, then sure, it ends up making a difference. And most of the Delphi RTL has been cleaned up. It's not every single place, but the largest majority to use const string parameters as needed, or when it makes sense. I said this, let me start going into the first small demo. Just shows some metadata around strings. It's nothing particularly thrilling, but so what does it happen here? I create a string. Notice I'm creating a string dynamically, because if you assign a constant string has a -1 reference count and kind of messes up. I mean, there is an optimization for constant strings that adds some complexity to the analysis. So here I have a string. I'm checking just the size of, which is the reference, and the length, which is whatever it is, and the ref count. I mean, there is a way to get the ref count of a string by simply using the global string ref count function. Then what I'm doing, I'm assigning 2 more strings to the same string, and then I'm repeating, getting the information and the ref count, which is what really matters in this case. Then I'm changing the first string, and again, doing the same operations. Okay, so let's see what this does. So you can see reference count is 1, goes up to 3, and then gets back to 1, because when there is this operation, the string is copied, and string 2 and string 3 keeps referring to that string in memory. String 1 reference refers to a new string in memory. So there is a copy operation happening here beside the, plus concatenation thing. Okay, the second is, there is a little more here about string references. Again, it's very similar. There are 2 strings. I guess these are actually... okay, these strings are assigned within the form. No, actually, they're global. I guess when the form is created, the string is assigned. So one is an alias of the other. And then when pressing the button, again, get the status, and then change one and get the status again. It's very similar to the previous demo. You can see the reference count is 2 and goes back to 1. Notice this string status gets the address in memory of the string. So when we are doing my string 1 equals A, what's going to happen is that the second string remains in the same memory location. The reference refers to the same memory location, while the string 1 is copied to a new location, and then of course both reference counts go to 1. So how does string status get the in-memory location? It's just grabbing the string as a pointer, and then going backwards, because there is some information at the beginning of the string so the string reference actually doesn't get to the initial beginning of the memory block. You have to go -8 to get to the beginning of the memory block, if for what it matters. Still. We could have done the same without the -8. Would still be relevant for, understanding if there are aliases and which of the strings gets modified. Last thing I want to mention, const parameters. So here is a simple stopwatch-based test that keeps track of 5 million executions of what? The calling simple function, calculate the length, which ends up like just calling length. But in one case the parameter is a regular parameter. In the second case, I'm passing a constant string. And so if we run the function, you can see that the time taken for one or the other, the time difference is actually very significant. So we really speed up the operations a fair amount by using constant parameter. Now, it's true that length is extremely fast. It's an inline function that just does a one memory lookup. It doesn't really have to go through the string to get the length. So that the difference is visible because the operation is extremely fast. For an average size operation, you don't have such a huge difference. But but it's significant. So you can really get some faster operations using const parameters. So next I want to spend a minute on reference counting for interfaces. It's been around since Delphi 3 or Delphi 4, I'm not actually 100% sure. So the core behavior is that whenever there is an interface reference, a variable of an interface type, when something is assigned to it, you get a netref function call. When it goes away, you get a release call. The implementation of addref and release is actually up to the class. There's no predefined default implementation of addref and release for interfaces. There are different implementations that are available. The interface object is a good one, has an active reference count, meaning whenever you call addref, the reference count is increased. Whenever you call release, it's decreased. If it goes to 0, the object is effectively destroyed. But for example, T-component implements interfaces and implements addref and release by ignoring them. So it's not really, it's really a do nothing. And so I think the singleton object, which is kind of a misnomer, again, has no reference count. So it's the actual implementation is ultimately up to the developer. However, in many cases, it makes sense to follow the interface logic and have some interface count. When you don't want to do it is if you want to mix objects and interface references, then you might want to disable the reference count. Although again, there are the using weak and unsafe provides further options I'm going to cover later. Of course, the advantage of reference counting is that when an object is not needed anymore, when there are no more references to the object just goes away, which is absolutely great. You have less worry in terms of freeing objects, keeping track of which references are available in memory, creating fairly complex ownership mechanism and notification mechanism to know, oh, hey, that object is going to be destroyed, set your reference to nil. So again, there is a lot done behind the scene. On one side, it adds to the runtime cost. On the other side, it reduces your burden. The problem with reference counting, and we'll see the same happens with arc for object, is cycles. When there are reference cycles, then the objects are not going to be automatically freed because the cycles will keep the objects live in terms of reference count. Okay, so let's look at some demos again here, and then we'll move to the actual main topic of the session, which is arc. In this very simple demo, I just have an interface with a couple of methods and a class implementing that interface. There are other classes, but we don't need to go through the entire mechanism here. And then this is the code. So all I have to do is create an object that does implement the interface. This is kind of an S-cast. It does an extraction of the interface from the target object, and the compiler can check that the class does support the interface at compile time. And then we just use the object, and when we go to the end statement, the interface reference is dereferenced and the object will be destroyed, and I have report memory leaks turned on, so we can actually see that when we are running the application and closing it, there is no memory leak here. So very simple model. Whenever you're referring to an object through an interface, you don't have that problem. Now we can also add another button and say this is just use an object instead. We want to change the code here, so rather than this code, we just go for the regular object usage. And then if we do something similar, in this case we do have memory leak. Okay, exactly as expected. Let's put a message here. Okay, so again, I don't want to get into too much details around interfaces, just give you some sort of highlight. However, there's another demo I want to mention, which is around the issues that happen. Again, there's a demo using an interface. The issue that happens when you're mixing objects and interfaces. Again, not the focus of this session, but somehow it is related. So what happens here is that I'm just using an object rather than an interface, and then I'm passing that object as parameter to a function that takes an interface parameter. Now this is legal because the object does support the interface. However, what happens here is that when I'm calling show that, the reference for this object is, the reference count is increased for this interface. And then when we go to the end of the function is decreased. Now it happens that it was 0, which is kind of illegal. And so it goes back to 0, even if there is an object reference. And so the object is actually is destroyed twice, and it should give us invalid pointer operation for that reason. Again, I don't want to spend too much time on this because the focus of the session is not interfaces, but just to have a few things clarified. So let's move to the main topic, which is Arc for objects. First thing, not all Delphi compilers support it. Mobile, Linux, and the iOS simulator, which is not technically a mobile compiler, support Arc. I'm going to show most of my demos on Linux. I think there might be one on Android. So Arc is automatic reference counting. It's a feature that's fairly used on other platforms. It was mostly pushed by Apple, originally in Objective-C and now on Swift. Swift adopts Arc throughout the board. There is a fairly complex and long document on the CLang site part of the LLVM compiler infrastructure website, which is a good reading. You can browse the internet and find a million discussions about Arc versus garbage collection versus manual management versus all other options, and it's debated. There are advantages and disadvantages to each model. Arc is a nice model because it's basically deterministic, meaning an object is destroyed, you're executing the destructor directly when the memory is deallocated. Again, in a deterministic fashion, even if it might be fairly complex to understand when that's going to happen. And it doesn't require a background thread or anything. However, of course, Arc suffers from memory cycles that, if you have objects referring to other objects and reverse, those objects will remain in memory differently from a garbage collected system. So, again, I don't want to get too much into that discussion, but mostly focus on how Arc works. All objects are reference counted in this model, well, with exceptions we'll get to. When there are no more standing references, so when the reference count goes to 0, the objects are destroyed, and it is very similar to interface reference counting. That's why I introduced it, and, well, to some lesser extent to string reference counting. Strings are more automatic because strings don't refer to other strings. You don't have cycles, you don't have loops. And the compiler logic is more proactive, like the copy and write mechanism. For objects, it's up to you as a developer to handle some of the more complex scenarios. So That's just a picture to show a reference cycle, because ultimately that's what we're going to discuss, because that's the key point. These are two objects. Each one has a reference, has a field referring to the other object, and so in the upper part of the image you can see a strong reference cycle. When the initial reference, when this reference goes out of scope, when this reference goes out of scope, each of the two objects has a reference count which is 1, and so they're staying in memory. One option that is available, and we're going to discuss it, is using a weak reference. When you're using a weak reference to the object, you still have a reference to the object, but this weak reference does not increase reference count. So here in this picture, each of the two objects has a reference count of 2. Here in this picture, each of the two objects has a reference count of 1. So when this, I was wrong. This object 2 has a reference count of 1, but object 1 has a reference count of 2. When the reference goes out of scope, they will each have a reference count of 1 and stay in memory. And the second option with the weak reference, each of the two has a reference count of 1. When the initial reference goes out of scope, the object 1 reference count goes to 0, object 1 is destroyed, and now object 2 reference count goes to 0, and object 2 is equally destroyed. So everything gets cleaned up from memory. Okay, so let's see, the basics of reference counting and the use of weak reference to break cycle, and we also need to discuss free versus disposing a little bit. We'll get back to this demo scenario. Okay, so for this first demo, I have a few classes here. Actually, I'm going to start with the arc experiments. So here there is a simple class. It has a constructor and a destructor, which just log the fact that the object is created and destroyed to let us track what's happening. And then there is a simple create only scenario. So I'm creating an object, I'm using it, and just letting it go. It will be interesting to notice when the object is actually destroyed. It actually destroyed when we reach the end statement here, because that's when it goes out. The reference goes out of scope and its reference count gets decreased. Okay. Now we have a slightly different way of calling it. This uses some traditional Delphi style code with a try finally block. You might want to keep using this code for compatibility, and this will equally work. So you can create the object, do something, calling free. Now the effect of calling free will be different depending if you're using a reference counted or not reference counted scenario. In a traditional scenario, free destroys the object immediately and calling the destructor. On ARC platforms, free in fact just sets the reference to nil, which means only if this is the only reference or the last reference to the object is destroyed. Okay, I think we can actually see it. Well, under ARC, the method is actually called. The compiler translates the call to a nil assignment. Okay. So in all practical terms, in this scenario, where there's a single reference, the code behaves exactly the same. So the object is destroyed when we free it, exactly in the same way on ARC and non-ARC scenarios. Now, there's slightly different option. That's something you should not do on non-ARC platforms, which is setting a reference to nil. There's also some exception handling here that happens if we pass through as parameter. As we'll see, this behaves exactly the same. So let's start to run this code snippet, and what I'll do is go to the main source code here, and disable this bit of the demo. We also don't need the read line. We'll get to see. So we are calling these three methods and see what happens. Let's do it. Okay, so let's back to our and see what we have here. The first is create only. The object is created. Something. Oops. Sorry. Something. And we're logging done, and then the class is destroyed. If we go to the try finally version, the class is created something. When we do free, the object is actually destroyed, and the done with try finally happens after the destruction. So in general, on the art platforms, you don't need to free objects or set objects to nil. You just let the objects go. However, there are cases that when you need the destruction or cleanup to happen immediately, and you have two options. If you have, if like in a simple case like this, there is only one reference, fine, just use free, and the free call will end up decreasing the the free call is converted to assign to nil. It's going to free the reference and destroy the object at that point in time, not later, not at the end of the method execution. However, this doesn't guarantee that the object is destroyed at that very moment if there are other references. If there are other references, nothing happens. So the other option you have here is to call dispose of. When you're disposing of an object on R, we won't see any difference here, but the destruction is forced even if there is another pending reference, another object referring to the same. So actually we do have an easy way to test it, which is have a second variable. So if we have my object 2 and we say my object 2 equals my obj1, okay, my obj, sorry. Now let's get back to the previous code with 3 and see what happens. So as before, try finally, created something. If you check here, done with try finally, and then the class is destroyed. So the code changed kind of similar to the first one, because the free does nothing here in this case. The free does not destroy the object. If we move it to using dispose of, we are forcing the destruction at this point in time, regardless of the fact that there is another reference, and this reference becomes a dangling reference, which is a fairly dangerous thing to do. But if you know what you're doing, you can go ahead with it. And so here you see try finally, my simple class destroyed, done with try finally. So the destruction is immediate when we're calling dispose of. Actually, it's not the in-memory destruction that's immediate. The memory is removed when all references are gone. What happens is that the destructor is called at the point of dispose of. So we're executing the destructor code more than freeing the object from memory. So the two things can be separate in time by forcing the disposal. None of the object itself, but any content or any other further resource reference the object has, which is the case that you might want to use it. Okay, the other one we haven't even focused much, but setting to nil, again, destroys the object and destroys it immediately. So the done is after the destruction. Okay. So let me now move to this other example, more classes. This is where things get a bit more complicated because now we have a cycle. We have this my little class that is owned by T my complex class, and the complex class has a reference to the little class. Now I'm using a weak reference for the back link, otherwise the two objects will stay in memory, create a cycle. So that's an example, a fairly classic example of two objects referring one to the other, and one is kind of the main one that has the strong reference, the other has only a back link to the main object and uses a weak reference for that. Okay. I think there's a demo of using those objects. Yeah, let's check this part of the demo. So I'm creating my complex object, and when I create it, it does create the internal object and sets the backlink. But again, the backlink being weak implies that these objects are properly destroyed. Okay, and I think they also log when they are destroyed. So we can see this code in execution here if we re-enable the this create only code in the demo. Let's save everything, run it, get to the output. So let's see what happens here. Complex class is created. Let me get back to the code. Complex class is created. Little class is created. Little class doing something. Okay, you can do something. Complex class is destroyed because the reference goes out of scope. As an effect, little class is destroyed. Now, what if I didn't have the weak reference? Let's try, but it's not going to be very good. So what happens now is that complex class is created. The little class is created, the little class does something, and the objects remain in memory because each of the reference counts too. Okay. Now you say, well, so weak references are just like pointers. No, that's not true. The weak references are managed. That's a very important difference from a general, reference that like in the non-arc world. And the issue there, and the thing that weak references solve is dangling pointers. So when you have like when you're creating two variables, object 1, object 2, referring to the same object in memory, if the object gets destroyed and those variables are not set to nil, you are in the scenario that you have a reference, object 1, the reference is valid, is some memory location, but you don't really know if there is an object there or the object's been already destroyed. And of course, there are lots of different patterns, notifications and other things you can use to handle the scenario, but they add quite some work and overhead. Weak references do the same at the RTL compiler level. Yes, they take some effort and there is a runtime cost. However, they remove a burden of doing the same yourself, writing all of the code and running it, which, most likely incurs in a similar runtime cost anyway. You think about notification and other things, they're not cheap. Like the component notification, when a component is destroyed, all other components in the same form and all their siblings, they all get a notification, hey, something's been destroyed. And then the same goes through from data module to form and vice versa. So you have like a flurry of communication and method calls that go all around to handle this same exact scenario. So let me explain better again with some code, and we'll get to the second bit. So let me restore this as a weak reference. Okay, so I have another class here. It's a separate class, and the separate class has a weak reference to little. which is this object. Okay, so the effective scenario I'm building is what was on that slide here. So I have my complex object. The complex has a reference to little. Little has a on by, which is a weak reference, but also my weak has a weak reference to the little object. Okay, so when my complex gets destroyed, what happens to this reference within the T my weak ref object? In short, what happens is that this F little is automatically cleared and set to nil. Okay, so and the scenario is this: I'm creating a complex, I'm creating the weak, I'm passing the little object there as the parameter, then I destroy my complex, and this destroys weak. Okay, now notice this code. I could have just had my weak little, or I can protect it and say if this is assigned. I mean, when you're using a weak reference and there is a chance that someone else goes there and hammers out the object out of memory, you can check if the object still exists, because it might have been destroyed. Of course, you can do the same in a non-arc scenario, but in a non-arc scenario, this makes no sense because little would refer to some memory location, and you know what? The object is not there anymore. For a weak reference, the compiler tracks the reference links and will set those weak references to nil. So in this case, I can do if assign, do something, if not, do nothing. And of course, we can play with, adding or not having this line of code. So let's for the sake of the demo, let's do it like this. Let's do it once, and then do it again to see what happens. So now that we have this initial test and we are setting complex to nil, let's see what happens to the runtime. And the fact is the two classes are created. Little doing something. This is the first do something call. Then we have the weak reference. We call through the weak reference and it does happen. So we have the second my little class. We set complex to nil. Complex and little are destroyed, and then when we try to call again, the reference is set to nil. So that's the kind of magic behind weak reference, that this is set to nil. Now you could, in theory, do a different type of protection, which is protect the access through helper method here, and then that helper would be implemented like checking the reference and eventually using it. The drawback here is that if you just say something but you don't stop the code from doing, you should kind of raise an exception. Hey, the object is gone. So somehow, yeah, it's true. You could check here, but then it leaves you a bit in trouble in terms of blocking the execution of a function if you have code like this, my little do something. So either way, there are multiple ways to implement this type of check, but remember, you can and should in most cases check if a weak object, a weak reference is still there when you are using it. So a few more things on Arc. There are ways to checking for cycles. In fact, there is a check for cycles methods. And then there's another concept, which is the concept of unsafe reference. We'll get to in another demo. Finally, in terms of optimizations, notice that passing object as constant has the same effect of passing strings as constant, meaning the increase-decrease reference count does not happen when you are passing an object as constant. It does happen if you're passing the objects as a regular thing. And I want to have some consideration about collections. But let's get to some more demos first. This is a very simple code. It has a class and it introduces another concept, which is unsafe. Using unsafe is like using a traditional reference, or kind of almost a pointer. A traditional reference with no reference counting. So this my object U and my object unsafe is not managed, behaves exactly like a traditional reference would. If you are assigning something to it, there's no reference increase. When you're freeing it, there is no reference decrease. You have to free, specifically free the object to get rid of the data. So free is not automatic anymore when you're using an unsafe reference. And I could run this, but it doesn't really show that much. So again, you can use weak, you can use unsafe. Both of them do not increase the reference count. However, they behave differently because weak are managed. So it will be set to nil when the object they refer to is gone. Unsafe references are not managed in any way. They will not be set to nil. They will still refer to some valid or invalid memory location, like references on the non-ARC platforms. I have a slightly different demo showing it, which is a demo focused more on performance. So what happens here, kind of trying to figure out how much overhead there is in using ARC on the Linux platform. And so what I've done here, I have a simple class, and I have a few different, and then I have two functions, one that has a traditional parameter and one has constants parameter. So I'm creating many being 2 million objects, creating 2 million objects, and doing something on them. So the code here goes on to creating the object in three different ways. In one case, it creates the 2 million objects and calls this method. In the second case, it does the same and calls method with a constant parameter. And in third case, it does the same using unsafe and then manually freeing the object in a try finally block. And if we run the code, you'll see that the non-ARC version is basically as fast as the const version, or kind of in between, while the first one is a little slower, and that's because of the function call without the constant parameter. So you can use unsafe in terms of as an optimization, or if you want full manual control, but it's not that it reduces or cuts the overhead in any huge way. In most cases, I mean, there might be specific scenarios where there is an advantage of using unsafe references. And in terms of collections, I have the simple demo does is adds a bunch of objects to a class and then checks the reference count. Of course, adding object to a list implies that the list has strong references. There isn't such a concept as a weak reference list or unsafe reference list. And so what happens is that the code will go through and create the objects, and each of them will have a reference of 1, although if you're using this code to check for the reference, you'll get a reference count of 2, mostly because this temporary object is an additional reference. So you need to create a new reference manually if you want to get rid of the extra phantom reference count. There is an interesting side effect of the introduction of ARC, and that's the ability to have operators for classes. So operators overloading is available for record. It's been for a long time. The same exact rules of record operators overloading apply to classes, but again, only for ARC-enabled compilers. The reason is that the operations on objects create intermediate results, and the memory management of those temporary variables will be close to impossible without either a garbage collection or an ARC-based compiler. In terms of code, that's a very simple code snippet. It's a number class, well, with an integer value. And I'm defining an add operator. So you can say object plus object, or an implicit conversion operator. So you can say integer to string, pass a t number, and that's converted into the expected parameter, which is integer. At the opposite, we could define an implicit operator that would convert an integer to t number data structure. So again, same rules for records, but applicable to class types. Finally, I want to spend a second on interfaces again, because since Delphi 10.1 Berlin, on Win32 you can have weak and unsafe interface references alongside with the traditional interface references. So this is a Win32 application, and in practical terms, having an interface and an object implementing the interface and this has a second reference to another object. So what you can do with this code is have a cycle. So the first object referring to the second, and vice versa. So without weak, this should cause a memory leak. That's the kind of the behavior we had in the past. Now we can mark our reference as weak reference, and the behavior becomes correct. Both have one interface count and not a higher one, and then they get destroyed. Alternatively, you can also have an unsafe reference. Now with an unsafe reference, the problem is that you have a memory leak unless you do something specifically. So if we hit unsafe, ref count is 0, so it's never going to be destroyed. Now you can call free on an interface, so that gets a little tricky, but you have to, I mean, this code really makes no sense in this scenario. But if you have like a secondary or additional reference rather than weak, which means managed and eventually set to nil, you can, if you need the fastest implementation, just go for unsafe. But remember that then if that object gets destroyed, you basically don't have a way to know what's up. With this, let me get back to the conclusion. Arc brings new memory model to Delphi. And it's a new memory model available for Linux and mobile compilers. Weak and unsafe have been brought back to interfaces on all platforms. And finally, you can get all of the demos that I showed under my Delphi session GitHub project. There are other sessions, but just go for the Arc memory model subfolder of the repository. And with this, let's open it up for question if you're listening to the live webinar. And if not, you can email me, or also you can follow me on Twitter for any further update from me personally and me as Delphi product manager. Thanks.
We do have Marco Cantu available here to answer some questions. So if you do have any questions, go ahead and put them in the question panel. Thanks, Marco, for being here and for putting that together.
No problem. Yeah, I was worried. They would say, "Yeah, there isn't that much to say about the topic," and well, I could have added even more. But yeah, I hope that was useful to understand some of the key elements. Um, and yeah, there are a couple of good suggestions from Roman in the question panel. Um, and then there's a very good question from Andrzej, sorry if I'm mispronouncing, about weak references are set to nil on the object being destroyed. This happens because for each class there is a list of weak references to object of that class. So upon destruction, the system checks against the list if there is any reference to that object that is being destroyed, and will set the reference to nil. This has runtime cost, because if you have like millions weak references in memory. It has been optimized a bit in the way the search is done, and also the fact that there is the list is per class. While I'm not sure about today, but at least in the past, Apple in their ARC implementation, they used to have a system-wide list of weak references, so that was even more slower to go through and to find those references. So it's true that weak references have a runtime cost, and the runtime cost is associated with storing and then looking up for references to the weak element. So don't use them, everywhere if they're not needed. However, again, as I mentioned, doing the same in code won't be much faster or much more efficient. The notification system Delphi has is great. The one that T-component notification and cross-code notification and notification list, but it's very complex at the very low level, and it has actually a very large runtime cost. Basically, every object you're destroying on any form, the destruction gets notified invoking a method for every other sibling. So if you have like 50 objects in a form, they all get notified when an object is destroyed. That's not cheap either. And though at times those notifications get spread out quite widely in the system. So it's another model. It's a nice model, but it's not a cheap model in terms of keeping all of the references around and the runtime cost when there is a component destruction.
I appreciate that you actually went into some of the detail on interfaces and other stuff like that, because they're all interrelated, as you pointed out, but it's also something that's really important to understand, especially, as you're working on different platforms and such.
Sure, and actually, there was a question in the previous webinar that was interesting. I was saying, the question was kind of the opposite. Say, oh, so why should we care about interfaces? Well, interfaces are actually quite nice, and now with the fact you can weak and unsafe interfaces, it makes them even more interesting. And you know what? Interfaces are really works the same across platforms, unlike the objects with ARC. So interfaces are actually more aligned in terms of cross-platform management than regular objects. And there are plans to bring, at least as an option, ARC on Windows. Or depending on the library you're using, well, still being discussed internally. But interfaces are actually very, very, very nice to use. And in the past, because of the loops, and because at times you need the extra optimization, there were problems. Now with the fact you can use unsafe and weak on interface references on all platforms, they actually became, since Berlin, even more powerful. So it's certainly something to always keep in mind as an option when writing some complex code.
Yeah, Nick Hodges' books on coding in Delphi talk a lot about the importance of interfaces as well. And I know I've used them in different times. Sometimes I use them for memory management purposes, other times for the loose coupling purposes. And
sure.
So there's lots of benefits of using interfaces and understanding them. I probably need to understand them better.
Sure, well, maybe we could do a webinar and just focus squarely on interfaces. I touch on the memory side of it, not on everything else. But no, it's a great feature that's it's still a bit underused internally, although I mean most of the newest libraries and sections use interface heavily. Like if you look at VCL, VCL has very limited use of interfaces because when the VCL was, I mean, the initial architecture was done without interfaces at hand. But if you look at FireMonkey, the way the platforms are plugged into the overall architecture, this is heavily through interfaces. I mean, each platform provides a bunch of services, and they're all interfaces. Anything that has a platform dependency, there's an interface for it. There's an interface for dialogues. There's an interface for forms. There's an interface for like platform services, for device integration, for making phone calls, whatever. I mean, it's really a large collection of interfaces underlying. I mean, there is a component model for the drag and drop component, but behind the scenes, if you look at how things are implemented, interfaces are actually used quite heavily compared to the DCL and other libraries.
Yeah, it was actually interesting. I had a conversation with, I realize we're getting off topic, but I used to work with a guy years ago doing Delphi development, and he commented about that, about what would the VCL be like, the VCL and RTL be like if it had been developed after interfaces were added to the language. And just recently I was talking to him, and he started going on about how much he loves FireMonkey and how much he, is looking for projects to do in FireMonkey now because, it's just such a more, it has so many improvements over the VCL as far as how it's implemented and working with it and stuff like that. Part of that being that, like you said, all the interfaces it has in it. So.
Sure. And then you can plug in, interface in the VCL to a moderate point. But I do have actually a bunch of code in that respect, but again, it's a bit out of topic.
Yeah.
Again, the point here was mostly, underline the fact that, Arc, the Arc model somehow comes from interfaces. If you look about the Delphi language, if you don't look like the rest of the landscape, of course, they really come from LLVM, Objective-C, and then Swift. The Apple side is squarely Arc-based, while the Microsoft and Java sides tend to be more garbage collected. And we could spend a lot of time debating, the two. It's a lot of online literature. There's not a winner. There are advantages and disadvantages for each of the two models.
Yeah.
I think for the nature of Delphi and for the fact that Delphi developers tend to be a little more to the metal than other developers, really going to a full garbage collected, a fully managed, memory managed model. It makes some sense in some respect. You have to kind of forget about memory in theory, but in practical terms, it's a problem. And when memory is tight, like on mobile, then it's even more problematic to go for garbage collection. There are some horror stories about garbage collection on Android, and when you put a .NET layer on top of the Java layer, you have like 2 layers of garbage collection that can really mess up memory in some pretty nice way. So there are many reasons I'm not much inclined to push Delphi towards a garbage collector model. Arc is, some people don't like it because it keeps away from being bare to the metal as well. It has some overhead, like creating and removing a reference, decreasing, increasing the count. There is some overhead, no denial at all. However, it also helps, a lot in memory management. So overall, I think it's a good model.
Yeah, I would agree. The garbage collection's got some niceties to it, but in my opinion, the non-deterministic nature of garbage collection is a real hindrance in development. And I've had I did a stint as a C# developer, and I had lots of problems with garbage collection. This whole concept that you don't have memory leaks anymore with garbage collection it's not true. They just behave differently. So, yeah, I think that the Arc is a much more elegant solution than garbage collection. So I was definitely glad to see that Delphi had that. I mean, I thought it would have been good for Delphi to have garbage collection, and then when I saw the Arc solution, I'm like, well, that makes better sense. That's a great idea. So I'm definitely a fan of that. All right, we should probably wrap up. Thank you so much again, Marco, and thanks everyone for joining us.
No problem.
So,
And again, the demos are available for download on GitHub. I shared the link before. It's GitHub Marco Cantu / Delphi sessions or something. There are actually a couple of sessions I did last week in Australia, and then this one. And I'm trying to put all of my demo code there because, well, I need a place, which is not just my hard drive. and I had other locations I used in the past and tried to put everything there. So the source code is there. It's not like astonishing, but there are some code snippets. If you want to use that as a starting point for further exploration,
yep.
Yeah, feel free to look at them.
Okay, great.
Okay, thanks. Bye-bye.
Thank you. Bye, everybody.
So, thank you, Marco. That was a really interesting session. There's so many different cool things that have kind of come in around the years with memory management, and Arc is certainly a very interesting topic indeed. So we've had a few questions come through. So if you have any questions for Marco, please do just put them into the Q&A, and we'll have a look at those as we come through. So I think, Marco, can you hear me okay?
Yes, I can.
Okay, awesome. So I think we'll give the obvious prize question to Alf today. Are there any plans for Arc implementation on VCL applications?
We are still discussing internally about how to bring Arc to Windows. I don't think we'd have Arc for VCL, but it would be great to have Arc on Windows for FireMonkey and server-side applications. So there's still some discussion going on. It's not something we're going to do in the short term, but it would be great to have a single model. And honestly, Arc has its quirks and its issues, but it's very powerful. On the other hand, breaking the compatibility in terms of memory manager for a lot of existing applications is very worrisome also for us. So the easiest way would be, okay, let's say everyone pick his memory model, but that has huge problem because the mix and match of packages and DCUs and other things would really be very difficult. So in part, the mechanism that we have today with Unsafe allows you to disable memory model, the Arc on as instance reference basis. Maybe there are ways we can figure out to have different options to disable Arc. So that's also a possibility. I mean, have it as a default, but not like compulsory. So again, it's an open field, and we're still researching and investigating.
Okay. I think more of a comment from Peter saying, hello, you're setting weak references to nil.
Yeah, that's, I mean, when I always get people worried because, oh, weak references are slow, and well, yeah, I mean, they slow down because they do quite a bit of work. Although we have a per class list of weak references compared to Apple that still has like a per system, so system-wide list, which is significantly slower. So I don't think it's a bad implementation. It does add, but again, if you consider what it takes to have T-component notification and the direct, I mean, whenever an object is destroyed, it notifies all of the parent notifies the siblings. If you have 100 components of a form, you get 100 method calls saying, hey, an object's been destroyed. Is it you? Do you have a link to it? And so it adds a lot of overhead as well. And even if you come up with something manually, yeah, you might be able to come up with something very efficient. But in general terms, managing cross links is tricky. So weak references have an implementation for that. And for example, like using those for interfaces in even in Win32 really opens up a lot of nice opportunities.
Okay, cool. David's kind of raised a question saying he's slightly concerned now, also because Arc only exists on some compilers, but the best way to write his code is so it works on the Arc and the non-Arc platforms.
Yeah, that's the reason we would like to have a more unified scenario and at least have the possibility to use Arc on Windows. A lot of code works fairly smoothly regardless of the platform. I mean, when you're working at the component level, a component use level, most cases you don't have to worry too much. Like you can either decide to go for free or dispose of depending on if you need like immediate destruction, and they both work on both cases. It's when you're building libraries that things can in fact get a little tricky. So if you like collection libraries and other cases, then it's not trivial to have code that works equally well and equally smoothly. So again, it's an open issue, and it would be ideal to have a single model, a single nice model, so that's something we're going to work on.
Okay, so Raina here asks, is const the string parsing equivalent to declaring an object as weak?
No, not really. I mean, passing a const string is like passing a const object. I mean, the concept of a const object in Win32 makes no sense. I mean, it's identical to passing an object because a reference is just a reference. On Arc, passing a const object, like passing a const string, implies that when there is the call and when the call returns, there is no increment and decrement of the reference count. Weak is more complex than const. Weak implies a reference that refers to an object that might get destroyed over time. It is managed, so whenever one of those objects get destroyed, the system will check if there is a weak reference to it and set that reference to nil. So it's a different model because it has more runtime support compared to just a const parameter.
Okay, somebody else is asking about Arc on Windows, which we kind of answered at the top. So the question really is from Matthew is just using try finally, free and nil. Does that still work on Arc?
Yeah, it does in most of the cases. So try finally you can use. I mean, it's just not needed, but you can use. The same for calling free. What happens, and I mentioned it at one point, what happens is slightly different. So calling free on desktop implies executing the destructor and effectively destroying the object. And then you generally set the reference to nil because you want to make sure that if the reference sticks around, you don't want to use it by mistake or be able to check if it's nil before using it. Yeah. Similarly, you can call free on Arc, but when you're calling free on Arc, you are just setting the reference to nil. However, setting the reference to nil on Arc is a significant operation because it implies removing a reference count and possibly destroying the object. Now, if on Arc you want to make sure you're destroying the object, you can call dispose of. And dispose of works on non-Arc just by calling free. So one option to have like equal behavior is to call dispose of. That implies you are immediately executing the destructor in both scenarios. So the question becomes, should we use dispose of everywhere? Not really, because dispose of is not Arc friendly. It's actually quite unfriendly. It kills an object that's still around in memory. So only if you need like get rid of this data, execute this destructor right away immediately because it's an open file. Yeah, at that point calling dispose of makes sense. But in general, just calling free or letting the object go is fine. So in most cases, keeping try finally free is good also for Arc.
Yeah, I think that's one of the things that's really quite nice is that when you're writing your Delphi code up, if you're used to using try, finally, free blocks of code, then that will work perfectly happy on your traditional platforms, and it will work absolutely fine on the mobile platforms most of the time, so unless you need to make sure you release a resource that's outside of the memory, really. And to answer David's kind of follow-on question about, I thought the whole point of Delphi was that you could code it once. Well you can, and that is the really cool thing. There are a few little things to look out for, which kind of Marco's been mentioning, but predominantly your code will still work across the two platforms. And although the behavior of the free differs between Arc and non-Arc platforms, it makes sure that it works and does what you need it to do. The only difference is something happening behind the scenes in terms of the determinant point that memory is released. So it's all pretty good. Yeah, and Matthew, the same thing really there is rather than just calling object.free, if you're calling the object free and nil, it's the same thing.
Yeah, free and nil just wraps, a call to free, so free and nil works also on Arc, with the caveat that on Arc, all it will do is just set nil the reference, and so destroy the object only if there is not another pending reference floating around.
Yeah, Frank's here put, how about changing free and nil to dispose and nil in multi-platform source? I think Marco's kind of answered that question earlier, that that has a bit of an expense in terms of the use of dispose. So unless you need to release something, if it's a socket or a file handle or something like that, then use the dispose. Otherwise, free and nil should do absolutely fine. Excellent. Some really good questions, and I'll give you a moment for anything else just to pop through. Marco, have you got any closing comments that you want to add?
No, I just want to mention that, there was in the previous slide was a link. I uploaded all the demos to GitHub. I created a repository some time ago with a bunch of demos for different sessions. And so that's one place to find all of the code. It's I understand it's tricky, and it's not. I don't want to downplay the fact that it's tricky. The decision to migrate to a different memory model was not a light decision, although the decision was taken before I joined the company. I think it makes sense. As much as direct native memory management allows you full control, it adds a bit in terms of burden. Arc with some automatic cycle detection could go a very long way, and we don't have that for now. There is all manual cycle detection, which is not the same thing. So there are different paths forward in terms of again making sure that this makes the code as cleanly cross-platform as possible. Although we're not far from it, but it's the difference. The memory model adds a little to the work for sure.
Awesome.
And interfaces work the same across platforms. So when using interface references, the difference is really minimal or close to non-existent between the two platforms. It's interfaces have always used reference counting, and they use reference counting throughout platforms, with the ability to have weak and unsafe references also on Windows.
Okay, great. Well, I don't see any more questions popping in here. So thank you very much, everyone, for joining us today. And Marco will be back online a little bit later on for the next one of this session. So if you do find questions between now and then, feel free to jump online later on. In the meantime, happy coding, and thank you very much for joining us.
Thanks. Bye-bye.